Topic to be discussed is process control and instrumentation. Begin with the introduction, that is basically the definition and importance of process control. Process control is a discipline that deals with mechanisms for maintaining the output of a specific process within a desired range. That is, it adopts various methods and specific tools to maintain the output of a specific process. Importance of process control is basically that it ensures safety, efficiency, and product quality in industrial processes. So we move on to some basic concepts under process control. We begin with control system. When we talk about control system, we mean the mechanisms, the algorithms that manage and regulate the behavior of devices in a process system. We move on to the open loop system. Here the controller's action is not dependent on the output and it operates without feedback. Last on the list is the closed loop system. The controller adjusts its actions based on feedback from the process. It continuously measures the output and also adjusts the input to maintain the desired set point. Next up is the components of a control system, which are the sensors, controllers, and actuators. With the sensors, they measure key variables such as temperature, pressure, flow rate, or chemical composition. The controllers are also devices or software that compare the measured variable to a desired set point and compute necessary adjustments. That is, they compare the measured variables, those variables that were measured by the sensors, to some certain set points, and they make the necessary adjustment to those variables. Last but not least is the actuator. It implements changes in the process based on the controller's output, such as adjusting a valve or changing the speed of a pump. Here we have the types of control system, that is the manual and automatic control. Manual control involves human operators making decisions and adjusting process parameters based on their observations and judgments. Operators monitor the process and make adjustments manually. Effectiveness relies on the skills and experience of the operator. It also requires continuous human attention and intervention. Also, human reaction times can also introduce delays in the process. But with the automatic control, it uses systems, that's hardware or software, to manage process parameters without human intervention. Systems operate based on predefined algorithms and real-time feedback, and they also provide consistent and repeatable control actions. They can react almost to changes in process conditions. They can also maintain tight control over process variables and reduce the need for continuous human monitoring and intervention. We move on to control strategies, that is feedback control and feed-forward control. Feedback control uses real-time measurements of the process output to make adjustments to the input, that is aiming to maintain the output at a desired set point. Adjustments are made based on the deviation between the actual output and the desired set point. Corrective actions are also initiated after an error has been detected. This can handle disturbances and process changes by continuously monitoring and adjusting. And with a feed-forward control, it anticipates disturbances by measuring them directly and compensating before they affect the process output. This adjusts the input based on predicted changes due to measured disturbances, and it acts before the disturbance impacts the process. It relies on accurate measurement of disturbances and an accurate model of the process. That is a feed forward control. Next up is one method that is under the feedback control. That is a PID control. PID is basically an abbreviation for proportional, integral, and derivative control methods. So the PID control. We are starting with the P, which is the proportional control. The proportional term produces an output that is proportional to the current error value, and this increases the output in proportion to the error, reducing the rise time in steady state error. Moving on, we go to the integral control. The integral term produces an output that is proportional to the accumulated error over time, and this eliminates steady state error by just adjusting the output continuously based on the sum of past errors. Last is the derivative control, which produces an output that is proportional to the rate of change of the error. This predicts future errors by considering the rate of change, thus continuing with the stable system and reducing overshoots. So combined, we have the PID control, that is the sum of the proportional, integral, and derivative terms. And with the tuning a PID controller involves finding the optimal values of the three terms, and this can be done by using various methods such as try and error, using softwares or tools to utilize the PID control. So we move on to some advanced control strategies, and we begin with the cascade control. The cascade control is a powerful technique for improving the performance and stability of control systems, especially in processes with significant disturbances or dynamic changes. By using an arrangement of controllers, cascade control can achieve faster response times, better disturbance rejection, and enhance overall control. Next up is the ratio control. It's a control strategy used to maintain a specific ratio between two or more process variables. It's very useful in processes where the proportions of materials or flows must be maintained within precise limits. And the last one we have here is the model predictive control, which is a powerful control strategy that offers significant advantages for managing complex multivariable processes with constraints. The success of MPC relies on accurate modeling, appropriate tuning, and efficient implementation. Our next topic is process instrumentation. And process instrumentation refers to the various instruments and devices used to measure, control, and monitor industrial processes. That is, the instruments that play a crucial role in ensuring process efficiency, safety, or quality. And the importance is that it's very crucial or vital for maintaining the efficiency, safety, product quality, cost effectiveness in industrial operations. Now we begin with some instruments for measuring various variables. We start with temperature. So we have temperature measurement instruments. We have the thermocouples, that is, they measure temperature using the voltage difference between two dissimilar metals. We have the thermistors, which measure temperature through the resistance change of a semiconductor material. And we have the RTDs. They measure temperature by correlating the resistance of the RTD element with temperature. We also have the pressure measurement instrument. We have the manometers measuring pressure using a column of liquid, the Baldwin tubes measuring pressure using the deformation of a curved tube, and we have the pressure transducers. They convert pressure into an electrical signal. We also have flow measurement instruments. and we have the orifice plates measuring flow rate by causing a pressure drop, the venturi tubes measuring flow rate by reducing cross-sectional flow area. We have some flow meters which include the turbine, electromagnetic and ultrasonic flow meters. We also have flow measurement instruments, and we have the orifice. We also have flow measurement instruments, and we have the orifice plate measuring flow rate by causing a pressure drop, the venturi tubes measuring flow rate by reducing cross-sectional flow area. We have some flow meters which include the turbine, electromagnetic and sonic ultrasonic. So we have here some analytical instruments. We begin with a pH meter that is used to measure the acidity or alkalinity of a solution, and is basically used in chemical manufacturing and water quality testing. Move on to the gas chromatographs, which separate and analyze compounds in a gas sample. This is also applied in environmental spectrum and chemical analysis. Spectrometers, on the other hand, also measure the properties of light over a specific portion of the electromagnetic spectrum, and is applied in material analysis and quality control. So from here we move on to safety processes in process control, or the safety mechanisms to observe in process control. We have the SIS, which simply means Safety Instrumented Systems. These are systems designed to prevent hazardous conditions. Such components include safety sensors, logic solvers, final control elements. We also have the HAZOP, which is the Hazard and Operability Study. It's a systematic method to identify potential hazards, and it enhances safety and prevents accidents. Now we look at some maintenance and troubleshooting ideas here. We have the preventive measures, that's regular maintenance to prevent failure. This reduces downtime, extends equipment life. And these are some common issues we face in the process control. That's calibration drifts, sensor fouling, communication failures, and even incorrect readings and signal loss. And the only solutions are regular checks, cleaning, recalibration, and repairs. This ensures continuous and reliable operation. So we all know the world is advancing, and therefore new technologies must be adopted in process control. So here we have emerging trends in process control. We have the Industry 4.0. That's the integration of digital technologies in manufacturing. And we have the IoT, that is Internet of Things, which simply means connecting devices and systems to the internet for enhanced control. And now we have AI among us, so we implement AI in process control. That's using artificial intelligence for predictive maintenance and advanced control strategies. So to end it all, we finish with a little summary, and that's process control and instrumentation are fundamental to maintaining efficiency, safety, and quality in industrial processes. By integrating various control systems, somehow industries can monitor and adjust processes in real time. The use of modern instrumentation and data-driven techniques further drives improvements in process automation and optimization. So this is all we have for process control and instrumentation.